It's fascinating to think about the universe we live in, right? I mean, just look around. The stars, the galaxies, the intricate dance of matter and energy. But what if I told you that the universe you see might just be one of countless others, all existing simultaneously in a vast cosmic tapestry? This idea, known as the multiverse theory, has been making waves in scientific circles. And it's a concept that's both thrilling and a little perplexing. So let's dive into this cosmic rabbit hole together. At its core, the multiverse theory suggests that our universe, this beautiful chaotic expanse of space and time, is just one bubble in an infinite sea of bubbles, each representing a different universe. Each of these universes could have its own distinct physical laws, constants, and properties. It's a mind-boggling thought. There could be universes where gravity is stronger, or where time flows differently, or even where the very fabric of reality is something we can't even begin to comprehend. Imagine a universe where you never had to worry about that awkward conversation you had last week, or one where pineapple on pizza is universally accepted. The possibilities are endless. Now, you might be wondering, how did we even arrive at this idea? Well, it turns out that some of the most cutting-edge theories in physics, like quantum mechanics, string theory, and the inflationary model of the Big Bang, have led some scientists to consider the existence of multiple universes. Quantum mechanics, for instance, suggests that particles can exist in multiple states at once until they are observed. This has led to interpretations that imply the existence of parallel realities, where every possible outcome of every decision plays out in its own universe. It's like an infinite choose-your-own-adventure book, where every choice creates a new story. But here's where it gets a bit tricky. Despite the allure of the multiverse, it faces significant skepticism from both philosophers and scientists alike. One of the biggest criticisms is the lack of empirical evidence. You see, in science, we thrive on data, on observations that can be tested and verified. Without tangible proof, the multiverse theory remains, in the eyes of many, a speculative idea. Philosopher Karl Popper famously argued that for a theory to be considered scientific, it must be falsifiable. In other words, there should be a way to prove it wrong. But the multiverse? It resists that kind of testing. It's like trying to catch smoke with your bare hands, elusive and frustrating. And then there's Occam's razor, a principle that suggests we shouldn't multiply entities beyond necessity. In simpler terms, if we can explain something with fewer assumptions, we should. Critics of the multiverse argue that proposing an infinite number of unseen universes complicates our understanding of reality unnecessarily. Why should we assume there are countless universes when a single universe could explain what we observe? It's a valid point, and one that makes you pause and think. Moreover, some skeptics argue that the multiverse theory blurs the lines between science and philosophy, or even science fiction. If a multiverse is fundamentally unobservable, can it even be considered a scientific theory? Theoretical physicists like Sabine Hossenfelder and philosophers like Tim Maudlin have raised concerns about the nature of scientific inquiry in this context. They argue that scientific theories should produce testable predictions. If we can't test the multiverse, then what are we really discussing? Is it science, or is it just a fascinating thought experiment? Now, let's talk about the fine-tuning problem. This is a big one. The universe appears to be finely tuned for life. The constants of physics are set just right to allow for the existence of stars, planets, and ultimately, us. Some proponents of the multiverse suggest that this fine-tuning could be explained by the existence of countless universes, each with different constants. In this view, it's not surprising that we find ourselves in a universe that supports life, because there are so many others where life isn't possible. But skeptics argue that this is just a workaround. It doesn't address the fundamental question of why any universe exists in the first place. It feels more like a philosophical evasion than a scientific explanation. So, where does that leave us? The multiverse theory is undeniably intriguing, and it aligns with some interpretations of modern physics. It opens up a realm of possibilities that can ignite our imaginations, but it also faces substantial philosophical and empirical challenges. Critics urge caution, reminding us that until we have observable data to support the existence of a multiverse, it may be more of a thought experiment than a reflection of reality. As we navigate this cosmic landscape, it's essential to maintain a sense of wonder, while also grounding ourselves in the principles of scientific inquiry. The universe, in all its complexity, is a source of endless fascination. Whether we're exploring the intricacies of quantum mechanics or pondering the existence of other universes, we're engaging in a quest for knowledge that has driven humanity for centuries. In the end, the multiverse theory invites us to dream big and think deeply. It challenges us to question the nature of reality and our place within it. And while we may not have all the answers right now, the journey of exploration is what makes us human. So, keep looking up at the stars, keep asking questions, and who knows, maybe one day we'll uncover the secrets of the cosmos, one universe at a time.